Hello, everybody. I'm the guy. Will be talking a little bit more uh, about the power plan on the coaches and the comment that I want to make about the DOT and CHP expansion. Cummins really welcomes any safety. We work very closely with regulators. It might be difficult to comply with certain things, but we do appreciate that because they do have an impact on the road and the safety with our families. I remember, as you probably see by now, I was not born in this beautiful land, but when you come here and see the order and have a better appreciation for that, so. You guys might be the guys who are dealing with it, and so it might be the difficult task, but I just want to give you some perspective. So my name is Daniel Polo. I'm the technical support manager. I work in the Pacific region mainly, so Alaska, Washington, Portland is kind of one of the areas that I really like the most out of my territory. But anyways, California and Hawaii too. Hawaii too, I like it. I don't get to travel too much there, so. So I recognize some of the faces that I work here. A little bit about my background. I started with Cummins about 13 years ago as an engineer. I was a service engineer. Now I work more on the marketing kind of technical capacity group. So I'll be talking just merely about the X12. And thank you very much for inviting me here in our group. So I'll get right into it. I'll try to keep it within half hour. If you guys have any questions or anything, just feel free to raise your hand and interrupt. We'll be talking to what's next after the ISX-12, what's the new engine platform. So might be some things are new. You'll see a little bit of marketing material, but it also I do have a very this engine, I work in the designing process on the export product overseas. So it's been a while since I know about these before I took these other roles. So a little bit of product overview. I'll be going over the development phases and ratings that we have in Motor Coach ratings. We're going to talk about the weight. Why? Because it's much lighter than competitors and the predecessor ISX-12. So that's one of the things that I wanted to emphasize. We're going to talk about reliability so far, even though from the design phases, what we expect and kind of forecast to see any reliability on that. And it's a bottom line friendly engine, so customer support too. The engine, it was a great design to my view, but I also like the fact that it comes with a bunch of us, meaning the front end of the business as marketing folks, but also there's service engineers and wide network of support. So let's get into it. So how do we come up with this platform? I guess I'll mention some of the aspects of or the path to get to these engines. So essentially on the 70s, you guys are familiar with the L10 technology that kind of evolved into M11 as the industry and the market demanded more out of that platform. We came up with the ISM platform. A lot of the learnings that we had there, we applied it into the what we called in 2014 the export product, which is the ISG 11 and 12. And the EPA market and the US market, we have the ISX-12. So essentially from those two platforms, we derived the X12, and that's a 2018 release engine. From the ground up, one thing to it's been one of the releases that we have from Cummins that we start from the block app design. Say that with a sheet blank of paper and decided to this block, we're going to make it lighter, we're going to make it modular, easy to work with. It's going to be it's going to be fit in different markets, and so that was the intent, hence the reduced weight. The other thing you might ask, well, you remove a lot of metal out of it, right? How you make it so light? So I think is one of the things that we've used on these engines. We use a lot of simulations software simulation. So we've done a lot of CAD, final element method on to see where is the meat that doesn't need to be there, right? So part of it is how we came up with those numbers. So a little bit of marketing stuff here. We were awarded as by the heavy duty truck within the top 20 products. And it was essentially because the design, the X12 design signifies innovation. And when at first everybody was in 2014, when we had in the export market, everybody was not really, well, let's see how he does, right? Well, 3 years after, we got an award because he's actually delivered the promises to a lot of OEMs. Some of the ratings that I tried not to kind of bore you with the details, but I wanted to put these up there. Essentially, we have a 410, 455, and 1450, 1550, 1750 ratings. Maybe Team, Dave, they can speak to what exactly we're going to be seeing and as a power plan of choice and ratings in your application. The other thing I wanted to mention is sim displacement. So one of the things that I do spend a lot of more time on the trucking side of the business. And one of the things when you go and talk to our end users that are familiar with the X15 is we love the brakes. We love the Jakes. So the performance, I put this chart here to have a comparison of what is spec from it. And I wanted to put it to here because if there's a driver that's complaining, well, I feel no brakes, so then we probably need to troubleshoot it because the engine compared to, if you look at if we follow the red curve, on the lower end range of the RPM is a little higher, it's not the same of the X15, or the X12, ISX12, I'm sorry. And compared to the competitors, we're right there. So we still keep that at a higher RPMs of 450 horse. So that's something that I wanted to make sure that there's not being a compromise in the design and the performance on the engine braking. So I'll get into the weight gains. For you guys, yeah, you might see maybe a little bit of too much of a marketing information, but I'll get into some of the maintenance aspects too. So the one thing I wanted to put up here is essentially we are right here. If you can see, we're around 2,200 pounds. The ISX12 combined with after treatment was about 28, so it's about 600 pounds savings. There was a lot of savings on the base engine, but also there were savings on the after treatment. We went to not complex, but a bigger assembly of after treatment from the ISX12 platform to a single module platform on these package. So that was a little bit, I'll talk about it, but there was a little bit of weight savings there. And this has been very, a lot of end users and other markets really have welcomed this improvement here. So a lot of and I apologize, I can't really put here maybe what signifies that. And I can really say, hey, maybe we can load up 3 additional guys like me, right? But in another application, you can see some of the examples here. What do you do with 600 pounds, right? We can carry 30 more cases of sodas, 97 gallons, 10 more bushels of corn. That would have been huge in my day. I grew up in a farm, so talking to my dad about this, probably that would have been the. Yeah, there. Well, not that kind of farm. You never know. There are different densities there, so I don't know what quality you're talking about. That's great, right? So that's a lot of, when you see the compounding effect of weight, that's one of the things that we are trying to deliver with this engine, right? While we're trying to go to electrification, which is good though, we're still not there with the technology to make it per se worthy, but on the diesel side, we are going there, right? We're making trucks lighter, coaches lighter, right? Not sure how relevant it is for you guys, but for other markets, been super relevant. So how do we accomplish that? So essentially, we went over external components and have been redesigned using the next-gen tooling. Essentially, a lot of computer optimization and going back and forth, a new breed of engineers, which is good and bad, but the good is right here, right? The good is that the guys who designed these are very, very smart with computer tools. And there was a lot of animation that I come from, previous to Cummins, I did a lot of simulation in the aerospace industry. And Cummins actually received a lot of that talent too. Because as you know, the factor of safety on an airplane is not the same on a coach. We can put as much metals as we want, bigger axle, another tire. We don't have that type of room on aerospace, right? And so it's possible, yes, if we apply the right tools and talents. But to go in more detail, where do we take that away from, right? So the one thing I work, when I did on the ISG product, I wrote some of the procedures for the overhead. And I never ranged for a living myself. I done it because I had to. I couldn't afford it. Working on a farm, you can imagine, never had a new equipment, right? So you had to, and I love working on this engine. I mean, I wrote the procedures to set the overhead lash, and essentially took me, find TDC, bar the engine over, next, done, right? The other thing is very modular. Like on this area, you can see kind of on hot side and cold side of the engine. We have the EGR cooler bracket with its round ribs. ECM bracket incorporates a fuel pump. Fuel lubricated high pressure fuel pump. Essentially, we are going away from the lube lubricated fuel pump. The other thing we did is all the cooling area is actually modular. So you combine pump, pulley, lube cooler, and bracketry, gaskets in one single module, right? Bolt up on the side of the engine. Same thing on the compressor. For instance, the fan rib with hollow pockets. I think I have an example here to show you kind of the process of how that works. I mean, it's more involved than that, but essentially we come up with an initial design. I said, hey, make it traditional, make it beefy, right? And then we do an analysis with the loads and constraints on computer, and then we do some way optimization. We go through another interaction, and then we have the final analysis, essentially. And that's kind of the derivable. Any questions by now? Good. It's durable. And it's been proven because we have over 1 million miles of real world. In fact, I test these trucks, 20 of these trucks here in Inner Mongolia in 2014 myself. We decided to pick, it was a very exciting and challenging project for Cummins because we kept it under a secret for almost 3 years. So guess where they took us, a bunch of engineers and test engineers. And the Gobi Desert, Inner Mongolia. And we tested there like for literally a year. I wasn't there for a year, I was there for 2 months, but it was quite the experience. That's the truck that you see there. Then we have some other markets as well. I think that's up there on the Alps. That one is in Australia. And if you see that truck in Australia, you guys know those guys mean business when it comes to trucking, right? So that's one of the pictures I wanted to show there. Let's get a little bit deeper in what it is. I mean, why I like this one, because it goes back to simple. When my dad and I in the farm, we used to have equipment. The good thing about the equipment, everybody will work on the Cummins in the 80s. You go to a little town, and that was simple mechanics, right? Especially overseas, right? So that's what you see. And in a way, we kind of went back to that, right? And still deliver on performance and emission compliance. So on the head, we have a 3-valve design. We have 2 intake, 1 exhaust. There was a little bit of trade-offs, yes. I mean, we know in automotive industry, we're trying to, how much heat and air we can remove out of that hole, right? We need more valves. We need a lot of stuff, how to control the valve timing and all that, right? I think that's where they're going, but I welcome that we work we took a conservative path. Why? Because yes, we require technology, performance, but also reliability. When we decided to go with a single exhaust port, we optimized exhaust port design with a view of improving the breathing of the engine, but also to create more room around it. And why we wanted to create more room? Because the water jacketing, so more room for optimized coolant jackets. Why we want more room? Because at the end of the day, you need to carry the same amount of coolant or water. But what if you, instead of the same amount of coolant water, you slow down the flow, the velocity of the flow. So then you're going to cut your losses. Therefore, you're going to make the pump more efficient. We're going to be moving water, yes, the same amount of water, but at different velocities. And so that was the idea that I really like about these. Yet the engine is running cold too. Then also the other thing is, and not so much is an issue here, and then maybe I can talk to you guys, but eliminates the exhaust valve bridges. We have more real estate there, we have more material there. So a little bit of a, I don't know if I can, I'll use it because an engineer told me once, well, we were talking about these, it's almost that you can, what do you do when you're breathing? You use two holes and use your mouth as an optimized exhaust hole. So that's the idea of it. A lot of people questioned me and said, hey, well, what happened with the X15 or the ISX12 2 and 2 ports, right? But it does work. I'm not sure if you guys are aware, but on our heavy-duty product, we also have the anti-polishing rings APR. We essentially, from the production dates, we went with this. If you guys are not really, has anybody heard about these? So essentially, the background of these is regulators are asking us, well, you need to control emissions in the hull too, right? But it's very challenging, and so we are being cold in temperatures, and we'll be too hot sometimes. Now we're hotter and higher pressures, and that's good. So I mean that the combustion process can be a little bit cleaner. That's great. But then we're doing these at a lower RPM. So that creates soot. Soot creates buildup around this area right here, right? A lot of carbon. So we put this anti-polisher ring right here. Essentially, every time that the piston comes up, we're scraping it, cleaning it. So the analogy that I wanted to work there is, what happens when you brush your teeth every day? Right, over your lifespan, your teeth are going to be clean. That's what we're doing here. So that was incorporated on the, and again, that was kind of the learnings that we did on the ISX12, on the X15 as well. So that was already incorporated on the production here. So some information here on, I'll move on into how much does it cost? How does it stack up against the ISX15? And that involves more on you guys. I mean, it is, the maintenance schedules is more frequent and things like that. I'll touch a little bit about it, but essentially, the biggest thing when it comes to total cost of ownership, I can talk about lower weight means same treats, more freight. For you guys, might not be the same, because I can tell you, you cannot put 3 additional Daniels in probably in the coach. Already cannot really put more seats, but maybe you're carrying less weight, and effectively you're carrying less, you're using less energy to carry that weight. Improved fuel economy throughout the engine operating range. Like I mentioned earlier, we sped down the pump, the coolant pump. We have a lower friction design and reduced parasitic losses. Extended maintenance intervals than ISX12. There's a little caveat here. Remember that I show you, yeah, we are delivering this big piece of iron, but also comes with some other products. At no cost, we also offer Cummins oil guard. Some of you might be familiar with it, but essentially that's a program. We don't charge anything for that. We just say, come to your fleet and say, offer the services of, we want to monitor what's the health of the oil throughout the life. And if we can squeeze a little bit more out of it, we'll come to you back with a piece of paper and tell you, Mr. Dave, you can change your oil every 50,000, 60,000, whatever the engineers and the chemists they think is appropriate for your truck. So that's what I mean by oil gar. We have extended coverage options, same as the ISX12 and the X15. Any questions about these? Good. So, and I apologize for these. The one thing I didn't realize, a lot of you guys, especially here in the Bay Area or Southern California, it applies some of the maintenance intervals, but it doesn't. Sometimes actually I rather go, and probably most of you guys go by the hours. Is that the case, Dave, or miles? Yeah, and take these as an example. Maybe that's something that needs to be talked about, because we do have a better control of the fluids that go into the engine now as a company. Yes, we make power, and Cummins actually is being known because, yeah, we make power plants. But now we're aligned with the company now. Last time I checked, we hired I think in 2018 and 2017, we hired the most numbers of chemists that we ever done in the past, because we're getting closer to that. Filtration is the same. With Fleegar, we have a pretty strict relationship because of this. I mean, we do almost kind of not so much out of the business model. It is a business, but out of necessity, because we realize that we need to keep close to these numbers, right? So in a lot of my customers here in California, even in the trucking business, I said, hey, maybe we need to look at these numbers by the hours. But essentially, here is the classification, oil classifications, the CES 200A6, which I think there's a note is equivalent to the CK4 in pretty light oil, 10W-30. And in that case, for instance, on these applications, recreational, refuse, and some applications like yours, it's actually 20,000 miles or 1,000 hours. Not really. As long as we meet the CK4, the biggest thing, the way that how do we looked at the oil health now? Essentially, when you send it into a lab, now you get the TBN and TAN numbers, right? I mean, besides the wear metals and all that, right? We went a step ahead and said, hey, we need to see oxidation and nitration and test that oil through different standards. We need to really understand exactly the physical properties of that oil over the life of that cycle. And so if you ask me synthetic, I wanted the oil that gets me, and again, there's a wallet there that you gotta think about. The oil that gets me the farthest, that's the oil that I wanna use, and not leaving money on the table, right? So that's why we put it right here. We want a lot of the customers that really want to lower total cost of ownership using the Cummins Oil Guard program. Now, I'll be frank with you. When we enlist one of our fleets in Oil Guard, it requires some of your commitment, some of your work, because that means actually we send you a bunch of bottles and kits to drain oil periodically, and you need to ship it to our lab. Then we come up with an engineer, and we do a meeting with you and said, hey, Mr. Customer, this is how your test has performed in 2 months, 3 months, 4 months. So it requires a little bit of work from you guys. But it's been successful on the trucking business. We've done it. I want to say that we have on the natural gas and the diesel side in California, I want to say that at least a dozen of customers, and the results, they've been great. We haven't compromised the life of the engine, and the customers have a increase in the total cost of ownership, or decrease in the total cost of ownership.
And that 80,000 miles, that would be regardless of the duty application, even severe, less than 5 miles per gallon.
Right. So we review that here's a table, right? That's what we give you to start with. But then what we do is actually we look at fuel economy. We want to see how much fuel you put into that engine, because that's equate to either the amount of work or the amount of idle. Both are bad for oil, right? And so then engineers, not only myself, but we have on the oil group team, we have group of engineers that we see that based on fuel consumption.
You guys are doing more warranties by hours now, run hours, right?
Depending on the market segment.
Like, I recently took a Freightliner that's got a Cummins engine, and they're looking more at hours runtime instead of how many miles were actually on the vehicle. Or warranty stuff.
There is a limitation of miles and hours when it comes to warranty. But depending also, warranty is allocated depending on the market too. On the market with that product intended. So.
EGR engine?
We'll get into that. It is a EGR engine. So how do we make that oil last a little longer? Apologize, let me see. Oh, so it is so how to make that oil last? So essentially, I don't know if you guys were familiar with the ISM 11, right? If you drain the oil on that engine, if you drain it completely, there's still 1.5 gallons on the head, right? On this engine, actually, there's not much real estate for that oil to stay up in the head. And so it drains directly to the pan. Another thing is we're trying to shorten the distance, so the mechanical work that you put on the oil through the pickup tube and all that. We have a pickup tube that is integrated to the pan. That's another way of saving weight, but also trying to put less mechanical work on that oil. And like I said here, there's no place for that oil to hide. The oil essentially returns pretty quickly to the pan, and this is just because of the lack of room or real estate on the head anyway. So composite oil pan, about 10.5 gallons, pretty similar to what you guys are used to on the ISX-12. The ISX-12 essentially, I think is when it's low is 9, and when it's high is 11. So or 10. Yep, 10 down. Okay. Yeah, it depends on the oil pan option. So when I put this light here, just to make the point. So essentially, in the cooling system, is efficient, right? Lower friction improves fuel economy from idle to interstate. We have a patent twin thermostat that keeps the coolant temperature stable. And I wanted to put this nice picture right here. That's your cooling unit right there. So you can bolt it up, bolt out. You have cooler, thermostat housing, you have the pulley and everything there. Your loop cooler is integrated on the pump as well. I like how, and again, I can only get creative with these slides, but marketing group said, hey, it's a common sense design. And I think it is. It's not only marketing talk here, but why? Because, and I guess a lot of the guys, again, I can't really say that I earn a buck wrenching directly, but probably indirectly I have. But it's a lot of room. I mean, compared to the ISX 12, X15, and there's a lot of room in the bay. And so that's one of the things that a lot of technicians are going to really appreciate. Serviceability, on the review, that was, I think, by far the engine that is easy to work on. Again, EGR cooler has cutaways for tool access points, a loop cooler module with easy access for above the chassis. That's actually a main thing on the trucking industry. The water pump pulley has a service access feature for easier installation and a self-tensioning belt. It's one of the things that we really like about that cooling unit and module. Dipstick and oil field mounted up high and forward. Again, that depending on the options that order with that, but I will imagine that in your case that will be an MCI or an van cooled. That will be the case. And we're learning from what we've done. I mean, we're trying to find a commonality in our product. So The comparison here is with the X15. So all the boxes that you see here that they're green are the same part of the X15. And then the trucking business is a big deal because we use the same common oil filter, the X15, the VGT, and the EGR valve. Actually, it's very similar to an EGR cooler, very similar to the X15. So there's no surprises here. It's the EGR engine. But then products and part numbers for stocking reasons we decided to go that route. It's a natural aspirated air compressor.
What's it drive off of?
The gear train is a rear-driven gear train, similar to what you have on the ISX-12. On the ISX-12, I think we have two, depending on the options. You have one in the front, a small one, and on the side, and then but your air compressor on the ISX-12 is running off the front. Yeah, this one is on the rear.
It's not mounted that far out.
Yes. Yep. And I mean, on the picture here is a single lung, natural aspirated. I don't know what will be, and that will be a good question. You guys already have pictures of that on your installations on MCI.
You have to look at it.
Yeah.
And the D15 for us.
Are we supposed to change the crankcase filter every time you change the oil?
Good question. On the X15, we don't have a crankcase filter. So I'm assuming it's going to be the same, but I can follow up and I'll be 100% sure on that. You take a note of that, and I'll send an email. Because we are going in that direction on most of our products. We're trying to go to a service-free crankcase filter, and that was on certain products every 60,000 miles, 70,000 miles. Yeah, so here's one of the slides that I really like about this engine. So what you see there on the picture, essentially, well, let me get to the first part. 25% of fewer parts than current ISX-12. It's got a modular design, saves techs from headaches when it's time to overhaul. So the cylinder head can be removed with a valve latch set. It means when you remove it, cam, valves, rockers, assemblies, and everything comes out. And the picture here shows only the head, but I've seen pictures that we can even remove with exhaust manifold, turbo, and the valve latch is still set. So for R&R or recon product, I think it's going to be huge, right? Very modular. So the EGR system can be removed sub-assembly. The cooling module design allows for easy access to water pump too. As I mentioned earlier, is one single module. Self-tensioning belt. We show that. They call it stretchy belt, which haven't tested as much that, and that's part of the option that I didn't get to test in 2014, but it depends on the market. I wonder, and that's actually a good question, did I request that for pictures on what will be on your application with the big alternators and things like that might be,
So this will get you home?
probably. Yeah, well, depends on the pulley size and the centers, the pulley centers too. So
So you stretch the belt and stick it on.
that's what it was promoted. I haven't, and that's the only thing I haven't gets my hands on. So can't really speak too much about it, but I can follow up on that. Now I wonder, the one thing that we wanted to see actually, I want to see what's the Fiat, the front accessory engine drive on a coach. Would be way different. You guys do way different things than the rest. So.
A lot of coaches downstairs to look at it.
Yeah, not with this engine, but yeah, I worked on a lot of them. And yours, by the way. So the heavy duty system architecture, some real quickly, I know we all want to go to lunch. So we have a turbo air gas pump through the turbo, goes through the CIC. Then we have air throttle mixed with EGR cooler. Then that charge goes through the engine. Then we do some work with the turbo, and then we end up in the DOC. We increase the temperatures of that exhaust right through the DOC. We have a DPF. We have a DEF doser. We have a SCR catalyst, and we have another catalyst right behind it. It's not showing the picture. We have the same kind of set of sensors. We have some set of NOx sensors, thermistors, and PN sensor. We have some DEF storage. We have a pumping unit as well, and we'll be seeing some of the things that the other things that I really like about these power plant. So essentially, we went through the single module after treatment, which is what you guys are used to there up at top. We went to the single module. We decided, and essentially, it's not like we did be small. No, it was a lot of thought about it. Well, we didn't need the real estate and the volumes anymore on the DPF. Why? Because we increase combustion temperatures and pressures. So that results on lower particulates, right? However, that results in higher NOx. So we will be relying more on the SCR catalyst, less on the DPF. So, and the other thing I really like about this engine too, which is great for your guys to do the cycle, right? So here, right, it's stop and go, a lot of traffic, because we are creating that pressure on the compression stroke at much lower RPM. Before we are burning cleaner and all that. So that's why on heavy duty system features, one of this is up to 60% reduction in space, because we decided instead of having a 20-liter DPF, we can do the work with a 15-liter DPF. And then we put it all in one can, right? Up to 40% reduction in weight. That's the other weight reductions that we found here. Yet, you can see it as on a single module, but it's modular. It means that we can take apart the DOC, take apart the DPF, service it, clean it, and do the work that we need to do. We still hear urea dosing, mixing, in the midsection of it. We have a SCR catalyst as well. So all components are modular and remain the same. Essentially, that resulted in reduced weight. The other thing that is not listed here, but we all learned probably in this room that in the last 10 years that the technology is all about heat management. And before we have to apply that heat management over a huge assembly, now we're concentrating that on this single module. Guess what? So we are going to be able to utilize that heat better because we don't have to travel from here to there with the same amount of heat. So the losses are great. So the system is more efficient. As a little bit overview, we're going to a different dosing system for the DEF system. So here's a little slide, talks about it briefly. So continuously circulates DEF to cool the doser, eliminates coolant lines to the injector. So that's another service item that doesn't need to be taken care of. It does not purge or shut down. And essentially it's a simplified system without a coolant plumbing. Have a picture here. We have the storage, we have a pump, we have the ECM ECU on these cases is controlling the dosing unit as well. And we have the SCR catalyst. So that's that for the engine side of things. I have put here a few slides that talk about customer support. So what is this engine made? It's manufactured in Jamestown, New York, built alongside the X15 assembly line, manufactured expertise with annual production over 100,000 engines. Is a reliable, we have a reliable, skilled workforce, about 1,300 employees, and is a team-based work system. Not so much like you see now on these pretty videos from YouTube of a bunch of automation and things like that. No, we can proud ourselves that a lot of these engines are handmade, and so that's part of these. Approximately 100 employee product engineering staff dedicated, what we call the current product team. That's actually US-based employees working on this engine as of now, right? Launching projects and all that. Put another nice picture of our what we call the Cummins sales and service region or distributor. We don't want to use the word distributors, or how do we divide the North American business and support. We went into the Central, Eastern, East, Gulf, Pacific, Rocky, South, and Western Canada region, essentially, for support. We had about 3,500 Cummins authorized service locations. That's really, when we talk to big fleets, that's a big deal. Essentially, that's a little summary here of what we talked about. So X12 limited production starts in October 2018. That's when we essentially decided some OEMs taking some of the orders. ISX12, as you know, production ends in December 2018. Savings, about 650 pounds. And it's a great, powerful, small engine that we've seen pretty good results in the rest of the world. Any questions?
So no one has this engine yet?
Freightliner has a press release, so they are putting it, I don't think they're putting it on the Cascadia, but they are putting on the SD. No, that's kind of little smaller gross weight than the Cascadia. I can't think of the model name.
Coaches, no one's gonna order it?
No, it's gonna be in production with us really soon.
So as far as coaches, I think you guys have something coming out in Q2, right? Van Hool, can't really expect for Van Hool.
I'm not sure. Van Gool loves to stockpile engines. So
Yeah.
they may have a supply of ISX-12s still to use up before they'll switch over. I know they've done the engineering on the X-12s, so it's just a matter of when the other engines are gone, we'll start seeing X-12s.
And that's a big.
I think it'll be this year.
So what Sam mentioned is that's a big part. The engineering, the engine is being engineered in Van Hool, and that's a big hurdle, right? It's a lot of time and investment from both sides. And even though there's a lot of commonality between the predecessor and this engine, but that's good. I mean, so as soon as it go through that pre-buy production of ISX-12s.
I believe the state of California gives it until June 30th before you have to take title. And after that point, it has to be certified.
Thank you.